Let's do question number 4. So again, I am concerned with a dipole, which is given by plus or minus 10 microcoulomb. The length of the dipole is 2a, which is 5 mm. So this is 10 to the power minus 6 coulomb. This is 5 into 10 to the power minus 3 meter. Now there are two parts to this question. Part, we are taking a point P. So this P is on the axis of the dipole and it is 15 centimeter from the center on positive side. So we have to find E at P. Now we also have the second part in this question, in which we have to find the electric force due to the electric field at point Q. Now in Q is nothing but it is again at 15 centimeter, but it is normal to the axis. That is the difference. So if you want to visualize this, let's get started with the first part of the question. So we have two charges, A and B. We keep minus 10 microcoulomb here, plus 10 microcoulomb here. That means the force will be acting on this side. Now we are considering this force at a point like this. This is P. Now this P is around 15 centimeter. How do we go about it? Now if you look at the distance, okay, I have not drawn this image to scale because this is 5 mm only. So this distance 5 mm, which is nothing but the length of the dipole, is extremely small compared to the distance r. So this is 2a, is much smaller when compared to r. So when we go for the formula E axial, which goes by 1 by 4 pi epsilon naught into 2pr by r square minus a square whole square. Now in this formula I could take a approximately equal to 0. So the moment you do that, it becomes 1 by 4 pi epsilon naught multiplied by 2 into P is nothing but 2a into q divided by this becomes r cube. This becomes r power 4, this is r, and they both get cancelled. So that's how it becomes r cube. Now to get the value of this, let's keep substituting the values. 9 into 10 to the power 9, which is the Coulomb's constant K. 2 into 5 into 10 to the power minus 3. Then Q is 10 into the power 10 to the power minus 6 because it's 10 microcoulomb. And then R is 15 centimeter, which is 15 into 10 to the power minus 2 whole cube. And when you solve for this, you get 2.66 into 10 to the power 5 Newton Coulomb. And there is also a direction, right? So this is acting in this direction. So I could put AB cap. That means this is acting in the direction of AB. So we found the magnitude. We also found the direction. Now the next question, we are altering the setup slightly. So we continue to have the same dipole A, B. You have to believe me when I say that this is 5 mm. However, it doesn't look like that at all. It's not to scale. Now I'm drawing a normal to this, and this is 15 centimeter, and this is the point Q we are speaking about, and we want to find the force at Q, right? So okay, now at this point we don't know how Q is going to act like. However, you would have studied in theory that if there is a point which is on the line that is passing through the center of the dipole, right? So that point is called equatorial in nature, because it is present on the line that is passing through the center of the dipole, equatorial point. For any point, equatorial point, or a point present on equatorial axis, the force, the electric field, acts parallel to the dipole axis but in the opposite direction. So dipole's axis is like this, so this is going to act anti-parallel, so it will act in this direction. So E at Q will be acting anti-parallel to the axis. So we could now get the magnitude. So magnitude again is given by P to 4 pi epsilon r cube. So we know the values already. P, I'll give P as Q into 2a by 4 pi epsilon r cube. If you substitute the values, so the Coulomb's constant 9 into 10 to the power 9, P is 10 to the power minus 5, Q is 10 to the power minus 5, 2a is 5 into 10 to the power minus 3, then r cube is 15 into 10 to the power minus 2 whole cube. This evaluates to a value of 1.33 into 10 to the power 5 Newton per Coulomb, and it acts in this direction. Our dipole axis is in this direction. Here is the fifth question from today's session. We have a setup, and the setup has two pairs of charges. That means there are two dipoles. So the setup looks like this. Okay, so this is a square A, B, C, D. So what I'm doing is I'm placing one dipole here, and then I'm placing another dipole here. So there are two dipoles. So the dipoles are placed in such a way that minus is here, plus is here. And in this case, minus is here, plus charge is here. So we have two dipoles. So this is dipole 1. This is dipole 2. Now, if I draw the diagonals in this square, they meet at O. If I draw the diagonals to the square, they meet at the point O. Now, our question is to find the magnitude plus direction of net electric field at O. Now we have to find the net electric field at O. So let's do this. So firstly, let's consider one of the dipoles. Okay, so let's consider this first dipole 1. Now we would want to consider the distance of this point from the center. Now what is the distance? So the square's side S is already given in the question as square root of 2. So that means this is square root of 2, this is square root of 2. This length r would be square root of 2 by 2. So we know that r would be exactly halfway. So r would be square root of 2 divided by 2, which gives us 1 by root 2 meter. So we know the distance of the dipole from the origin, from the point we are considering O. Now we would want to find the electric field at O due to dipole 1, which is AB. So we write the electric field at O due to AB as E1. Now the formula for this, 1 by 4 pi epsilon naught into P by r square plus a square whole power 3 by 2. Now this is for equatorial electric field. This is the formula for that. Now in this 1 by 4 pi epsilon naught, I am taking it as k. And then P, I could split P as Q into 2A. And the rest I keep as they are. So if we solve further, KQ into square root of 2. But R we have already seen is 1 by root 2 square. A is also 1 by root 2 square. Now what is A? Now let's look at this. A, so 2A is root 2. A is equal to root 2 by 2, which is 1 by root 2, which is what we have substituted here. So if you do 3 by 2 of this, we get E1 equals square root of 2 into KQ. This is the magnitude of the electric field. Magnitude of electric field at point O due to the first dipole. But this is not enough. We should also find the direction of this. Now let's look at the direction. So if you look at the dipole's axis, so the dipole's axis, it is going to be in this direction, right? Now here we know that it will be anti-parallel, so it will be in this direction, anti-parallel. So you could go for AB cap. It is acting from left to right. Now this entire setup is symmetrical. Now if I had to calculate the force, the electric field at O due to dipole 2, I will write it as E2. That is equal to the same magnitude. There is no difference. It's the completely same output we will get. But let's look at the sign here, the direction. So the direction of this dipole axis again will be this. And we are looking at the direction of the electric field, which is in this direction, opposite, anti-parallel. So the net force, both the forces are in the same direction, right? Which is root 2 plus root 2. I take KQ outside equals 2 root 2. K is nothing but 1 by 4 pi epsilon naught. That is the answer. Now this is parallel to both AB and DC. So the resultant force, if I could show this, is going to act in this direction. Resultant force. We are going to do one last question today. So this shall be our question number 6. So in question number 6, so we have a setup again of 2 different dipoles, and they are placed on the XY axis. So this is the XY axis, X, Y. So the first dipole is placed here. So let's take it. The charge is, one charge is here at A. Let's call it plus Q. The other charge is at here, B, that is minus Q. There are 2 charges. Now that constitutes a dipole. Similarly, we go for another dipole. So this is placed vertically. So I am keeping plus Q here, minus Q here. This is C, this is D. The place where they both intersect. It's actually midway. That is O. Now the dipoles are identical, equal in magnitude. The size is all the same. Now we are looking at the magnitude and direction of net electric field at O. So we want to calculate that. How do we do that? So we take firstly E1. E1 is nothing but the force at O due to let's say P1. Now P1 is going to act in this direction, this dipole moment. Now the other dipole moment would act in this direction. Remember, it is always going to act from negative to the positive charge. So due to P1 there is an electric field. It is given by the formula 2 into 1 by 4 pi epsilon naught into Q by A square, and the direction of that is going to be the same as it is going to be, the direction of that is going to be the opposite of the dipole axis. So it will be acting in this direction. It will go towards the left. It is opposite, equal in magnitude but opposite in direction to the dipole axis. So to the dipole moment. So Q by A square, and that is, I can write it as OB, unit vector. Similarly, the electric field at O due to P2, right? So we could write it as 2 into 1 by 4 pi epsilon naught into Q by A square. And here again, so the dipole moment is acting upwards, so we will be experiencing E2 in this direction. So this is E1 in this direction. So I put this as OD cap. Okay. Now you could see the magnitude is the same, E1 plus E2. That is magnitude, right? So I mean, you if they are in the same direction, let's say there are 2 vectors in the same direction, E1 and E2, we could get the magnitude as E1 plus E2. However, we have the vectors exactly like this. Okay, so E1 is acting in this direction, E2 is acting in this direction. So in this, if you would want to calculate magnitude, we have to do E1 square plus E2 square, which is the same. Both are the same, which is square root of 2E, which is 1 by 4 pi epsilon naught 2 into root 2 by Q by A square. This is the value we are looking at for the magnitude. Now let's speak about the direction. So we saw that. So let's one more time go to the comprehensive, outlook at this. So firstly, we have our first dipole moment P1 is acting here. The electric field due to that would be E2, E1, which will be acting in this direction. Then the other dipole moment is acting in this direction, that is P2. Then the electric force due to that, electric field due to that would be acting downwards, that is E2. Now if you look at it, we have a setup like this. So the resultant is going to act in this direction. Now because E1 and E2, they are same, then the resultant is going to be at 45 degrees. So if you take it from x-axis, this is 180 degree plus 45 degree. So resultant, or nothing but the net electric field is at 45 plus 180 is equal to 225 degrees counterclockwise from x-axis. This is how it looks like. This is how it looks like. Thank you. All these notes, as I told you, you could view it in the description. This, the ideal way to do this is to open the notes and follow along as I take you through the explanation. And if you have any thoughts, feedback or comments, please do let me know. It would help me make better content for you. Thank you.